So now let's talk about our proof of contrapositive and how we can set things up. Very similar to last time. I'm going to leave this table here. I'm not going to read every single bullet here. But again, 3 and 4, finding our mathematical definitions, and then 4, getting it to lead to our negated Q, negated P this time, is what we're after. And you're going to see that pretty heartfelt here with some of the examples that I have here down at the bottom. Now again, this time we're taking a different route. We tried the direct route. This time we're going to try the indirect route where we're literally negating our Q and P, which we talked about in the last video, so I'm not going to belabor that. Let's move on to our example. In our first example of contraposition or contrapositive, we have our statement that's already set up in our P implies Q form. So you're probably thinking, well, I probably could use direct on this. Yeah, you actually could. In this example, what we're going to do, though, is we're going to do a simple flip to go ahead and get it into our negated P and our negated Q form. So again, notice, I could have done directed on this one, but this one I'm doing our contrapositive for an example. So all I'm doing is flipping. So notice, by the way, the overall setup of the question is still the same. You'll notice P is still on this side. You notice that Q is on this side. But what I've done is, instead of it being odd, I've made it even. There's odd, and then there's even. So that's how I get away with my negated P and my negated Q. Very simple. That's it. For part 2, all I'm going to assume is that the N is even. Again, that was my negated Q part, so I'm just assuming that part's negated Q is good. Number 3 is, again, I'm worried about the P portion, negated or not. I'm worried about the P side of the equation. So what I'm going to do is I'm going to try to find something that's even. We know what the equation is for that, so we're going to end up using it, you've seen this before, as we move on to number 4. So for part 4, we're going to focus on that P side of the 3n plus 2, and we're going to try to manipulate it, adding our 2k in there so that we can end up having a form that looks like our even, which is that 2k. Well, we do some very simple multiplication and then some factoring back out, and darn if we don't have that form of 2 times something, which is exactly what we're looking for on our even, and that's part 5 as we do our substitution, where 2j is the same form as 2k, and that's where j is equal to k plus 3 plus 1, or 3k plus 1, sorry about that, where k is integers. Then we do our conclusion, therefore is even, and then you can read the rest of it. But notice how, again, we did it from reversed and we negated everything, and it still ends up being right that we're okay with it and that, hey, we're okay with how the overall statement was set up. Now notice, by the way, in this, we are saying that we are using contrapositive. So notice at the end, n is an integer and 3 plus 2 is odd. That's from the original statement. Notice I don't say not even. You don't have to put that in there. I did. And that n is odd, not even. So notice we're back to the original theorem that we had for our proof. And example number 2, very similar, but there is a little getcha on this one, so just a heads up on that one. Prove that for an integer n squared is odd, and then n is odd. So it's already set up on our P implies Q situation with an if n, and that's good. But as you know, we're going to end up negating something here in a moment. So that's number 1, is if n squared is an even number integer, then n is also an even number integer. Notice that's been flipped. We're going to assume that the negated Q portion is true for number 2. Number 3, we're talking about even again, so you know this equation is going to pop up. So in part 4, again, I'm focusing on the n squared, but I have n as 2n. So what do I need to do to get n to n squared? I frankly square both sides to get my n squared to get my p portion. And then I start solving it from there to go again, get it back into my equation of the 2k. So you'll notice that, again, some minor trickery on how we want to do this, but again, the focus is the p side. I got it by squaring n, and then I have to square the other side. So notice it's a little different on this side. We have 2, and then times 2 times k to the second, or the power of 2. And then 5 is, again, there's my pattern that I want. There's a 2k, there's a 2j in this example, where j is equal to 2k. There's my substitution. And then we can basically say, and notice, by the way, it even says this, I like this one a little bit better. It says even by contraposition. We really should put that really in the other one that I had up there. Matter of fact, I might change it and add it slightly here. Just to say, hey, we did this by contraposition using our negated p's and q's in order to do that. So here is our result and our stamp at the very end.